Howdy folks, we're going to work on maybe not our first, but essentially our first Java program. So I'm going to fire up IntelliJ here, and we'll see if we can't start working our way through chapter 2 here. So there's a lot in chapter 2, so we're going to break it up into a couple different videos so it's not everything all at once. So let me get this started here, and then I'll make a new project in our course repository so that you can always go back and reference this code later on. Again, that course repository is linked here in the content section. Go to course information, and then you can find the course repository here. Will take you to the GitHub repository page for the course. So all of our stuff from chapter 1, our Hello World project, was out here from last week. And then as I commit and push the stuff from chapter 2 today, it'll show up here as well. So that's where you can go and reference it. So to make sure my code makes it into that repository folder, I'm going to make my new project. I'm going to pick that location. So that's the big step. Once you've cloned your repository, you need to know where it is. So I'm going to go and start a new project, and I'm going to put it inside of my course repository folder. So when you're working on your lab assignments, when you're working on your projects, you'll put them in your lab or project repository folder, not this one that's mine. Right? So each of yours will have your own, and I'll talk you through that first lab exercise, or lab 2, a little bit later on as we go. So this will be chapter 2, and I'll put it in 1500, summer 2022. It's going to go inside of a folder inside of that folder, which is great. That's what we want it to have happen here. And I'll do it in this window, so this other one will close, and we'll start up a new one here, and we can get going. So the first thing we're going to talk about here in source, right, we're going to add a new package. So a new package is the right way to do things. It's not necessarily required, but it's bad form to not have a package here. So the package I'll just call chapter 2. So the package is nothing more than a folder. Now inside of that folder, I'm going to put a Java class. That'll be my Java file. We'll call this chapter 2. So I'll have a chapter2.java file, and you can tell this add, don't ask, or cancel. It doesn't really matter one way or the other here. It wants to be helpful, and if it's giving you errors about Git not being installed, that's okay. You don't need to worry about that. We're going to use the GitHub desktop client instead of the built-in Git tools. That way you just learn one tool instead of each individual environment's tools. So it should give us some starter code. We see it has a package because it's inside of a folder, and then it has public class. Now the class name here has to match the name of the file. That is a hard and fast rule in Java, and the convention for class names is you should start with a capital letter. Again, not entirely required, but it's a strongly held convention, and people are going to look at you funny if you don't have capital letter class names. So this is chapter 2. Now, when we name things, there are a few things we can't use, and we'll get into some of those as we go on. But generally, start with a letter. You can include some numbers if you want, and then every next word will get a capital letter. So again, I can't really write any code here yet. So what I need is that public static void main, or PSVM, and all of our code will start between these sets of curly braces. Those are the syntax rules for Java. So when Java goes to run an application, it's going to look for something that says public static void main and start there. So once we're in here, we can start then making our own program. So we have last week, all we did was a bunch of print line commands, which is fine. So we said system.out.println or SOUT and then tab. We said hello world. Right? This is a command, a statement. It will run this Java code and do that. Again, not the most interesting thing, but I'll go ahead and run it. So we'll run chapter 2, and then I can get my run button in the top right here again, and we'll see it should spit out hello world if everything worked right. Takes just a second to get going here. There we go, and we see down in our output section, we see hello world. Awesome, so it ran the Java program, and it does some other fun stuff behind the scenes here that we could do if we really wanted to, and it ran the chapter 2 dot chapter 2. So chapter 2 being the package, chapter 2 being the class name is what it did here. So everything got compiled to this out folder. Right out here there's a chapter 2 class file, a chapter 2.class. So .class is the compiled Java bytecode. Right? This is the Java virtual machine readable code, not human readable code here. So we take human readable Java files, they could compile to class files, and then the Java virtual machine on whatever operating system is running will run that code, which is pretty fun. It's a really interesting system, and they were actually pretty original being cross-platform a while back. So Java is pretty cool at that. Okay, but anyway, these are just print commands. They're not very interesting right now, and we can't really do a whole lot with just print commands. So we want to be naming things nicely. So our class name, right, capital letter to start. But then inside of our program, we want a place to be able to store information. If all we ever do is print things, we're not going to be very useful. So what Java lets us do is store different kinds of information. And Java will ask your operating system, hey, operating system, I need space to store something in memory. So memory is your computer's RAM, the random access memory. It's really fast, but it is temporary. If your computer shuts down, you're going to lose everything that's in RAM, and that's intentional. It's not long-term storage. It's like working memory. It's like your short-term memory. You're not really storing it for a long time. You're holding it in your head for a minute. You'll recall it, and then you're done with it. So what we can do then, we can declare a variable and assign that variable a value. Two different steps that happen. You can do them both at once. You can do them separate. Depending on whatever your format is, that's okay. So the quick variable type we're going to look at of numeric types of values. So integers, or ints, are whole numbers, actually negative and positive whole numbers, somewhere around negative 2 billion to positive 2 billion. We'll look at those maxes and mins later. Not that important, but within 2 billion or so, plus and minus is an integer. And then if you're going to use a number with a decimal place, in Java we're going to use those as doubles. So double is the easier type to use. There's a couple other types we'll get to as well, but those are going to be the easy ones for us. So if I want Java to store an integer, I'm going to say int, because that is the type of value I'm going to store. So int is the type here, and I'll say this is my favorite number. Now I'm going to start with a lowercase. So variable names will always start with a lowercase letter, and then every next word gets a capital letter, so that when your eye looks at it, you can catch, okay, this is my favorite number, and it's kind of easy to read. If I did that all lowercase, my favorite number, it's a little harder to pick out, well, what is the correct, the start of each next word here. So this is called camel casing, kind of like the humps on a camel, right? So, and you can have these as long as you want. A good rule of thumb is that your variable names should be descriptive of what they're being used for. So when you see the variable my favorite number, you know that it's probably going to be my favorite number. So we'll assign it the value of 42. Now, again, we end with a semicolon. So all of our statements, all of our commands in Java will end with a semicolon. This equal sign here is not the equals operator. It doesn't mean it equals anything. This is known as the assignment operator. So we're saying, hey, take the thing on the right and assign it to the value on the left. So we're going to take the value of 42 and assign it to this integer called my favorite number. What that means then is if I want to print, I can print my favorite number. Now notice this is not in quotes, right? I can put in quotes here. I can say my favorite number is, and then I'm going to use the plus sign to append in my favorite number here. So it's going to take this as a string and then take an integer value and stick it on the end of that string. So when we're in our program, what Java does is when it sees this variable name, it says, oh, hey, operating system, go get me the value stored there and give it to me. So in this case, we stored the value 42. We assigned it to my favorite number. So somewhere out in our computer's memory, we assigned the value 42, and it's in binary, if that's interesting at all, so a bunch of ones and zeros, to the my favorite number location in memory. I don't know what that location is. Really, I don't care, because Java will talk to the operating system and figure that out. And every time we're going to go use it now, it just says, hey, go look this up. Here's where it lives, here's what lives in your memory. Go give me the value back out. And we can get that back out. So that's an integer value. You can also have double values. So doubles are numbers with decimal places. So this would be a number with a decimal place, or number with a decimal. Sure, let's say like 7.7. So 7.7 gets assigned to the value number with a decimal. Now what's really cool here is these variables here can store this information as long as the program is running, but if we want it to change, we can change it. So if I change my mind and say, oh, my favorite number is not 42, I can change the value stored in my favorite number. Now, here's where this was sort of useful if you want to do this in two steps. So you can say int, this is your number, and just put a semicolon. This here is declaring a variable. So we're telling Java, declaring, there we go, let's spell that one right. We're telling Java, hey, ask the operating system for a place to store an integer. Don't give it a value, just ask it to hold a place for you, kind of like a placeholder. Then we can say your number equals 10. Now you can assign a value. Assign the value 10 to the variable your number. So wherever your number is in memory, we're going to assign the value 10. So right now it doesn't have a value. Here, once we assign it 10, it has a value. So you have to be, you know, I don't really like doing it in 2 steps. I prefer the single step here. Oops, sorry, that's so this is, let's figure out that cursor here. This is declare and assign, right? I like this way. That's my preferred way here. Now, there are some good reasons to just declare variables, but we'll get to those later, where you might not want to assign them right away. But I like doing it in 1 step because, you know, I'm a little lazy and I just like doing things with less typing. So knowing that you can assign a value, you can change that value as well. So I can say your number now, how about equals to 12? And really, again, it's not the equal sign. We're assigning the value of 12. The thing on the right gets assigned to the thing on the left. So we'll change the value of your number now to 12. So we can even print it out. We can say, hey, your number is, in quotes here, your number is, and then, oops, we can append in your number. And then I'm just going to do this again after I change it to 12, and we'll see that it changes. Let's give this a run. We'll see your number is 10. My favorite number is 42. Your number is 12. We've changed the value of your number. So a variable can only hold 1 value at a time. Right? It previously held 10, and then we're changing it, saying, okay, forget 10, now you hold a 12. Your value is going to be 12. So we can declare our values, we can assign our values, and then we can do something with them if we want here. Right? So I could also then say, if I wanted, this number with the decimal is equal to 12.1. I can change the value, right? I can give it another number with a decimal. Now, Java's a little bit fun in that smaller types of numbers can fit into bigger types of numbers. So doubles are actually much larger than integers. You can store really big numbers and really small numbers here. I forget the actual range for doubles. Let's we can Google that one real quick. So Java max double here is 1.7 times 10 to the 308. Sure, so you can have 308 place values in there. Holy cow. So that's really big, right? So an integer will definitely fit inside of a double. That's okay. What you can't do is you can't fit a double inside of an integer, right? So a double can hold an int, but an int can't hold a double. So if I were to say your number equals 7.7, it's going to yell at me here, and I get this big fat red line that says require type int provided double. I had to give it something that's an integer, and I tried to give it a double. It's no good here. This won't work at all. Okay, so that's actually going to fail. I'm going to leave that one commented out here. And these double slashes, I don't remember if we talked about this last week or not, are comments. So it tells the Java compiler, please ignore this line. So anything that comes after the double slash will get ignored. Okay, so there are a couple, again, reasons or ways to name values here, a couple rules around them. So you need to start with a letter. They can include numbers, but they can't be the first one. We want to, generally, they should be nouns, right? Or descriptive nouns with some sort of adjectives describing them. That'll be meaningful. Now, Java could care less, right? We can say, hey, I want an int A is 10, an int B is 20, and an int C is 30 here. So Java doesn't care about our variable names, about your variable names. People care about your names, right? And you is people, me is people. Other people who are going to work and support our code are people, right? So you might remember what A meant for the next hour when you're working on your project, but after you go to lunch and come back, you might not remember what an A means. Like, why am I calling this thing A? And when I look at your code, I'm going to have no clue what an A means and why you've called it A and what you're using it for here, right? And then if you get into software, you learn more about it, you can take our software engineering class with Mr. Haiti. He'll teach you all about the software development lifecycle. Most of the time, right, when software is written, it spends the majority of its existence being used. That's in the maintenance phase where we're maintaining the program, because software is expensive. You have to pay developers who make good money to write the code, and it's not the fastest thing in the world, right? So if it takes you 3 months to write a piece of software that does something, the business isn't going to turn around in a year later and throw it away, right? The business wants to get a return on their investment. If they paid a programmer 3 months worth of salary to get some program, they're going to use it for a long time. And you know, we're all going to start off as junior developers, and that's okay. We're going to start with small things and develop our skills and get better and better and better. That's one of the coolest things about the software industry, that you're always learning and always getting better and evolving, so you can move on to bigger and better things. Right? It doesn't really pay to stick with the company year after year after year after year, because you can just transfer to another company and get a faster raise. Right? You know, you're definitely going to beat the raise. Hey, a 3% raise was great this year, and you're like, no, I could just transfer and get 10 or 20% raise in my salary. So go to another company. Every couple of years, move around, get more experience. What that means is someone else will be responsible for maintaining your code after you've moved on to bigger and better things. Now, there's a chance here, and it's not a large chance, but there's a chance that the person who comes after you is a psychopath. And they're just crazy, and they're going to come hunt you down and yell at you for writing terrible code that they can't read. It's not a big chance, but it's definitely a non-zero chance that could happen. So we're going to write code for people. Right? Your people, I'm people, and our coworkers are people as well. So at least in the academic setting, you need to know what your code's doing, and then I need to be able to read your code to evaluate it. Right? There's not really anyone who's going to come after you to maintain this code, because we're just writing it for academic purposes. But in the industry, right, someone else will come along and have to maintain your code, and we want to write that for people. So we need to use nice variable names, not garbage variable names like this. Okay? Not A, B, and C. So that's naming our variables, that's using integers and using doubles. The other fun thing you can do is you can assign a variable another variable. So I could say, hey, I have that, what was it here? This was a number with a decimal. Let's give it the value of your number, right? And what that does is it says, hey, Java, go get the value stored here and assign it to this value here. So now if I print out the number with a decimal, the decimal value is, end my quote here, and append that, this concatenation, right? It'll take the string, stick the letter on, right? We should get your number when we're done, right? It's now notice 12.0, we still get the 0.0 because it can hold a double here, but it's just saying there is no decimal place essentially, and your number is still 12. Okay, so you can assign one variable to another variable as well. All right, folks, why don't we pause here and we'll come back and pick up the next section here in the next video. Thanks, everybody.